Okay, this video is on the law of sines and cosines. The law of sines and cosines are used when the triangle is not a right triangle. And you can still find all the pieces of the triangles, all the sides, all the angles by using the law of sine and cosines. Okay, so number one, they gave us the numbers, the angles 29 degrees, side C is 110, well, angle C is 110, and side C is 49 degrees. So if they don't give you the ABC triangle, which Alex always does give to you, which is really nice of them, if they don't give you the ABC triangle, just draw your own triangle. It doesn't matter what side you call, what angle you call A and B and C. You just make a triangle. Don't worry about angle sides and just label it A, B, and C. And then side A is across from angle A. Side B is across from side B, and so on. So the first step is you fill in the numbers they gave you. So I filled those in. A is 29 degrees, and then fill in the C, it was 110 degrees. And so it's very easy to find the third missing angle on this one because there's 180 degrees in a triangle. Subtract the other two, and you have the missing angle. The law of sines comes in handy on this one. If you can circle, so I think I did, which one did I do over here? I did B over here. All right, if you can make with two like oblique circles or ellipses, if you can make two of those and inside you have 3 out of the 4 pieces of information, then you can use the law of sines. Here I'm just missing side B, so I can use the law of sines on it. The law of sines says that the side across from the angle across from it, the sine of it, is equal to any other side of the triangle and the angle across from it. And then also like side C across from angle C, you're not using all 3 pieces of the formula here. You're using 2 of the fractions out of 3. You don't do all of them. And so the one that's really good to use here, I set up 2 equations down here. So I'm going to use the side that's 49 over the sine of 110. I'm going to use that twice. I went ahead and just set up 2 at the same time. So 49 over the sine of 110 is equal to side B over the sine of 41. Likewise, it's equal to the side A across from the sine of 29. And so those are the 2 proportions I'd set up to find the missing sides A and B. And then you cross multiply and divide to get the 2 answers of 34.2 and 25.3. The only thing you need to be careful on in this step is that you hit equals here, or use parentheses. If you're going to try to put that whole chunk in your calculator at one time, you're going to need to use parentheses around the top and then divided by the sine of 110, or hit 49 sine 41, enter, and then divide by the sine of 110. And I have to warn you, if you haven't used your calculator a lot, it's got a couple modes on it here to figure out what an angle is. And your calculator, unfortunately, comes, if you have the fancy TI calculator, it comes already in the mode of radians, and you need the mode to change the degrees. All right, let me get my calculator. All right, so on your fancy calculator, turned on, and then you need to go to the word mode, which is right up there by the second key. After you go to mode, you're going to go down to radian degree, and yours probably says radian if you haven't done anything with it yet, if you've never done radian degrees, and then hit enter, and then go out of it, and now it's in degrees. All right, next one. The next one's a little bit more work. I'll work it through it for you here. So again, the first step is to put the numbers on the picture, which I did. And I was able to make an ellipse here with the angle and a side. And the same thing over here. I've got the side and the angle. So I'm going to have to do that one first. There's not 2 of them really quick to do like there was on the last one. The last one was easier because they gave us 2 angles, and all we had to do was subtract from 180 to get the third angle. And then from there, we were going. All right, so on this one, setting up the one law of sines that we can do from it, 58 over the sine of C is equal to 52 over the sine of 38. Cross multiplying, dividing, you're going to get this function. So you get 52 sine C equals 58 sine 38. We want to get the sine of C by itself, so you have to divide by 52. So I'm going to go ahead and find out what that number is for you. I would take it to at least 4 places. This is called an intermediate computation that we're doing right now. So we need to take it to 4 places. So on my calculator here, I am going to do 58 sine of 38. I'm going to hit equals and then divide that by 52. And I got to 4 places, 0.6867. So then doing second sine, you have to hit second on your calculator and then the sine key. So it makes inverse sine or sine to the -1. And then you're going to put in that number, 0.6867. And it gives you the answer then of 43.369. So that's to the nearest tenth, 43.4 degrees. Now this is where it gets kind of interesting if you haven't done trig yet. Your calculator gives you back the answer from the first quadrant between 0 and 90 degrees. It can also have another angle that's equal to it. The sine wave, let me draw the sine wave for you here. There's the sine wave. So your calculator is giving you back the answer right here in the first quadrant of it, but there's another one over here that's equal to it too. So what you got to do, just right here, just do this each time, you guys. Doesn't matter that you haven't learned trig yet. You're going to go 180 degrees minus whatever that angle was, and you get the other possible angle here, which is 136.6 degrees. So the angle could either be 53.4 or, again, the quick answer here for you about what you're doing, you're going to take 180 minus that angle, 43.4 degrees, and you get the other possible angle, 136.6. All right, so then using both of those numbers, the third angle in the triangle is going to be 180 degrees minus the one angle that they gave us, 38, or minus the 43 or minus the 136, which gives me 2 other possible angles for A, 98.6 or 5.4. And then you have to set up the whole proportion twice for those 2 other angles. So we got 52 over the sine of 38. We know that's true. And then we want to find the missing side A. And then A could be over either the sine of 98.6 or over the sine of 5.4. Because we said A is either 98.6 or 5.4, which gives us the other 2 possible answers for A. So this only happens, again, for the law of sines. If on the law of sines they only give you one angle out of the 3, you're going to have 2 possible angles for the other ones. And sometimes it's not even possible. If you try to find the other angle, it's going to make a triangle that doesn't even add up to 180 degrees. It's more than that. So sometimes it's not possible to have a second triangle. That doesn't happen every single time. All right, number 3. It says Jessica and Raphael are standing on a riverbank, 130 meters apart, points A and B respectively. They want to know the distance from Jessica to a house located across the river at point C. Jessica measures angle A to be 47 degrees, and the one by Raphael is 54 degrees. All right, so I made my circles again. And this missing angle, since we knew 2 of the angles, we know the third angle, it has to be 79 degrees. And so then I set the proportion again. X over the sine of 54 is equal to 130 over the sine of 79. Cross multiply and divide, and you get that X is 107.1 meters. Number 4, we're going to have to use the law of cosines on. All right, so for the law of cosines, again, fill in the information they gave you. They gave you A is 28, B is 51, and side C is 66. So they didn't give us any angles at all. So if you were to try to make circles out of the information they gave you, you're not going to have 3 out of the 4 pieces of information. You're going to be missing stuff. So that's where the law of cosines comes in. So on the law of cosines, this is one of 3 of the law of cosines. They're all the same formula. So you take one side, A squared, and then the angle across from it, you're going to do the cosine of it. So A squared is equal to the other 2 sides, B and C squared, minus 2 times B and C, and then the cosine of A. So whatever side you're squaring, you're taking the cosine of that angle. And the one that you're not squaring, you square the other two numbers and minus 2 times both of them. So on this one, I went for angle A first. We want to find angle A. So trying to find angle A here, it's across from the side that's 28. So this is the side I have to square. So 28 squared is equal to 66 squared plus 51 squared, minus then those two numbers multiplied together, cosine of A. All right, so next I did 28 squared minus the 66 and minus the 51. And so when I subtract those two off of 28 squared, because right now it's plus 66, so move it to the other side, it's minus 66 squared minus 51 squared. And that gives you negative 6173. This is one chunk right here. That's where a lot of people make a mistake. These are all multiplied together. Figure out what that number is. That number is negative 6,732. So then you have to divide by it, and that is the cosine of A. And we want to know what the angle is, so then you have to do the inverse cosine of that fraction. So I just did the inverse cosine of that fraction. Again, two negatives make a positive. That's why there's no negatives there. And that gives me to the nearest tenth, 23.5. And then I did it again to find another angle. This time I went for angle C. So angle C is across from the side that was 66. So 66 squared equals 28 and 51 squared minus 2 times 28 and 51 cosine of C. Again, angle C is across from side C. Side C, 66 squared, and then square the other two sides and add them together. So again, take the 66 squared minus the 28 minus the 51 squared, you get 971. Multiply that whole chunk out is negative 2,856. So then it's the inverse cosine then of 971 over negative 2856. And just a small note here about a negative sign on a fraction. You can put the negative down here, or you can float it up here to the top, or you can put it in the middle of it. People don't understand the whole fraction is negative. It doesn't matter where you stick the negative at. You only get to use it once. Just put it somewhere on the front of it. So if you wanted to, you could have floated it up to the top. Anyway, then we got 109.9 to the nearest tenth. So the missing angle, this would be the last step, step 5. The missing third angle then would be 180 degrees minus the 2 that we just found, and that was 46.6 on this one. All right, number 5. On number 5, we get to go through a tunnel. Joe wants to know the length of a tunnel built through a mountain. To do so, he makes the measurements shown in the figure below. Use these measurements to find the length of the tunnel. So we know this angle 77. We want to know that side. And then they also gave us the other two missing sides. So we don't have another angle at all. It's definitely not going to be the law of sines, but it's enough to do the law of cosines. So we want that side, which is across from this angle. So x squared is equal to the other two sides squared minus 2 times those two sides. And then the cosine of that angle, that's 77. So you can put that whole chunk in your calculator at one time. Again, this is an intermediate computation here, so I took it out 5 places. And then you take the square root of that, and that to the nearest tenth then was 226.4. Number 6. On number 6, they want us to find the area of that triangle, which the formula is 1/2 the base times the height. We know that side's 13, but we don't know this side. These are the two sides that make the right angle. The two sides that make the right angle are the base and the height. It doesn't matter which one you call the base or which one is the height, but we are missing one of the two sides that make the right angle. So I'm going to use trigonometry to find it. We've got this angle was 42. That side we know is 13. We want to know this side. Using that angle, this is opposite from it. This side is adjacent to it, and we don't care about this side at all, but it's the hypotenuse. But we're not worried about that side. We got 2 out of the 3 numbers. You need 2 out of 3 to do sine, cosine, or tangent. Just like the law of sines, you need 3 pieces of information out of 4 to be able to work it. You can only have 1 piece of missing information. So anyway, the tangent is the opposite over the adjacent. And so that gives me, again, it's an intermediate computation. So I took it out 4 places. So then the area is 1/2 that number I got for A, 11.7052, and then times 13. To the nearest tenth, then it's 78.1. Number 7's a tricky one. It's tough. You're going to need, you could do it a couple different ways. Let's go down and look at number 8, and then we'll come back to number 7, because there's 2 ways you could do number 7. Number 8, they gave us 3 sides without any angles. Whenever that happens to you, you're going to use this formula called Hurons Formula right here. And the area is equal to the square root of the letter S times S minus A squared times S minus B times S minus C, where S is equal to half of all the sides added together. So you have to have what S is. So S on here would be all the sides added together, 11, 14, and 15. And then you get to take half of it, so that's 20. So by Hurons formula then, the area of this triangle is S, which is 20, times 20 minus one of the sides. It doesn't matter what side you call A, just pick one. So we'll call it 11. And then 20 minus 14 and 20 minus 15. And I got 73.4846, and so to the nearest tenth, it's 73.45. 73.5. All right, going back to number 7, you could use Hurons formula on this one too. What I did to do this one was I dropped a right angle for fun, and then I used some trigonometry on it and the law of sines and cosines to find them. But honestly, probably the quickest thing to have done on it is the law of cosines to find that missing side A. So A squared is equal to then 5 squared plus 9 squared minus 2 times 5 and 9. And then the cosine of 142, and you'll get A then is 13.3016. So you could use Hurons formula on it then, 5 plus that 13.3 plus 9, and then do that whole formula we did down here then. That would probably be the quicker thing to do. I went through a whole bunch of other work to get it done by dropping that right angle and using base times height and 1/2 it. So you could do it that way if you wanted to. You can look at my work, hit pause if you want to do it that way instead. All right, you guys have a good day. Bye-bye.